Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the unit circle. So the unit circle has its center in the Cartesian plane at the origin. Unit means its radius is 1, so it goes 1 unit in all directions. So we can use this to define sine, cos, and tan. So let's draw a right-angled triangle here. Now the radius of the circle is 1, so that side's 1. Now we'll just call this distance here x, and then this distance up here we'll call y. So if we make theta the angle made here with the positive x-axis, now we have sine theta equals opposite over hypotenuse, so it's just going to be the y value. Cos theta adjacent over hypotenuse is going to be the x value. And then tan theta, see, it's going to be opposite over adjacent. It's going to be y over x. Tan theta is actually y, which is sine theta, over x, which is cos theta. Okay, so why is this important? Well, we're going to use this to figure out the value of sine, cos, and tan of angles that are not just between 0 and 90 degrees. So for example, let's say that theta were 30 degrees. So it would mean that this distance here is sine 30, which is a half. This point here has y coordinate equal to a half. This distance along here would be cos 30, which is root 3 on 2. So what we're going to do is we're going to define the angle made with the positive x-axis. Sine of that angle is whatever the y coordinate of the point is, and cos of that angle is whatever the x-coordinate of that angle is. So let's say, for example, we wanted to find the value of sine, cos, and tan of 150 degrees each. So how would we do that? We were used to using sine, cos, and tan in right-angled triangles, and certainly a right-angled triangle doesn't have a 150 degree angle, but what we're going to do is use the unit circle. We define theta as the angle made with the positive x-axis, and we're always going in an anti-clockwise direction. So if I want 150 degrees, this green angle will be 150. But notice that would mean this angle here has to be 30, so that it makes a straight line. 150 plus 30 equals 180. So if I draw a triangle here, notice that the green and the red triangle, they would have to be congruent. So what it means is this distance here will be the same as this distance there. It also means this distance here and this distance here, they would have to be the same since the triangle's congruent. So this means if you draw a line here that makes a 150 degree angle with the positive x-axis, it will hit the circle at this point. Now it will have the same y value as this point, so that will be a half, but the x value will be the same, but it will be negative. So that's the coordinates of this point here. So we said that sine of the angle will always be the y coordinate of that point. So sine 150 is a half, cos 150 is the x coordinate of the point, which is root 3 on 2, but negative. And tan 150 is just going to be y over x. It's sine divided by cos. So a half divided by negative root 3 on 2 gives you negative 1 on root 3. And so we can do that for any angle in this unit circle. Let's say I wanted to find now sine, cos, and tan, and let's do 225. So we can easily find that using the unit circle. So 225, its angle would be all the way around here. It would be 180 plus another 45. So this acute angle in here would be 45. Now notice that the point here would have the same value for the coordinates of x and y as it would if we drew 45 over here. So if this angle here were 45, we know that the coordinates of this point would be x value would be cos 45, which is 1 on root 2, And then the sine of 45 is also 1 on root 2. That's the coordinates when the angle's 45. When it's 225, it's down here. Now notice, again, we have congruent triangles. These two triangles in black are congruent. So this point here, it would have the same value for the coordinates, except they'd be negative. The coordinates of this point would be -1 on root 2, -1 on root 2. So that means that sine of 225, which is the y value of this point, would be -1 on root 2. Similarly, cos would be the x coordinate of the point. Now tan 225 would be y divided by x, sine divided by cos. In this case, it would just give you +1. So you might have seen a trend there. In this quadrant, quadrant 2, when we found sine, cos, and tan of an angle, only sine was positive. That's why I put an S there. And in this quadrant, the third quadrant, only tan was positive. That's what the ASTC means. Quadrant 1, all of them, sine, cos, and tan are positive. In this one, only sine's positive, only tan is positive, and only cos is positive. So you might remember it with some acronym, like all students take calculus, whatever you want. So just make sure that you do know it. So basically, this is how we find the sine, cos, or tan of an angle outside the range 0 and 90 degrees. We just find a corresponding angle that is between 0 and 90 degrees. All right, this is very useful in solving trigonometric equations. So let's go ahead and do that. So we're going to find all solutions between 0 and 360 to each of the following. So here we have sine of x equals -1 on root 2. Now it turns out your calculator can give you one solution, but it won't give you all of the solutions. So what we need to do to find this out, we need to find a corresponding angle in quadrant 1. So let's first look at solving the equation sine x equals not negative but +1 on root 2. Well, if we know our exact values, we know that x equals 45 degrees. Sine of 45 is 1 on root 2. We also know that sine is negative in the second and third quadrants. So this is the story so far. We know that sine of 45 degrees, where it intersects the circle, y value will be 1 on root 2. So when's it going to be -1 on root 2? It's going to be in this quadrant and this quadrant here. Now both of these angles here will have to be the same. They will both have to be 45. So this first one here, it corresponds to an angle of 180 plus 45, which is 225. So the first solution here is x is 225 degrees. Now, this solution over here would be an angle of 270, 360 minus 45, so 315. So these are the two solutions. X equals 225 and 315. Generally, there are two solutions to a trigonometric equation like this, unless you have a coefficient in front of x. So let's solve 1 minus 2 cos 2x equals 0. So firstly, we want to get everything but the cos over to one side. So we're going to subtract 1 and divide by -2. That actually gives us cos of 2x is equal to 1/2. So let's figure out where cos of 2x equals 1/2. So when does the cosine function equal 1/2? Well, hopefully you remember that cos 60 equals 1/2. So one possible solution is 2x equals 60, which would mean x equals 30. But when else does cos equal 1/2? Well, we figured out one solution was here at 60 degrees. Now, we remember that it goes ASTC. We want cos to be +1/2. It's positive when it's 60 degrees in the first quadrant, but also in this fourth quadrant. So what we're going to do is draw a line down here, and that angle needs to be 60 degrees. So the angle made with the positive x-axis going all the way there is 360 minus 60. Another solution here is 2x equals 300. 360 minus 60, which means x equals 150. So when we have a 2 in front of the x, it actually doubles the number of solutions. So instead of expecting 2 solutions, we are going to expect 4 solutions. So it turns out if you add 360 to an angle, it doesn't change it. So 30 degrees is considered the same as 390 degrees, for example. If you add 360 degrees to something, you don't change it. Now, when there's a 2 in front of it, we can just add 180 degrees to the solution. So the other solution will be 30 plus 180 and also 150 plus 180. And these will be the 4 solutions. So generally there are 2 solutions to an equation like this, but you need to multiply the number of solutions by the coefficient of x. Now just a note, if you're told to find the solution in radians, so here we were given x in degrees, if you're told in radians, you can actually just solve it in degrees and then convert your answers back to radians. Alright, let's now look at 2 harder questions. So this time I'm asking for the solutions in radians, but as I said before, we can solve it in degrees and just go back to radians. So sine x equals 2 cos x. How do we solve something like that? Well, what we can do is divide each side by cos x. We really only want a situation where there's one trigonometric ratio to contend with. And the reason we divide by cos is because sine x divided cos x is tan x. Cos x is cancelled out, we get tan x is equal to 2. So this is not an exact value. You can use your calculator to come up with one solution. So x will equal the tan inverse of 2. Now that actually is about 63 degrees. So that is one possible solution. What's the other possible solution? Well, we can draw up our unit circle. Remember, it goes ASTC. So tan is positive in the first quadrant. It will also be positive in the third. So we need to make this angle made with the x-axis 63. So the angle we're looking for here is 180 plus 63, which is 243 degrees. So both of those solutions will work, but we were asked to provide them in radians. So remember, the way you go from degrees to radians, you simply times by pi over 180. So for 63 degrees, timesing it by 1 pi over 180, you get about 1.1 radians. And 243 times pi over 180, you get about 4.24 radians, and we're done. All right, let's solve 1 minus cos squared theta equals 0. So just so you know, cos squared theta is actually the same as cos of theta squared. The reason that we write it like this is we just don't want ambiguity. If you put cos theta squared, it might be a bit ambiguous. Are you squaring just theta or are you squaring the whole thing? So what we're going to do is we're going to subtract 1 from both sides. We get minus cos squared theta equals minus 1. Of course, you can change the sign of this side as long as you change the sign of that side. So we have cos squared theta equals 1. So that means cos theta will either be 1 or cos theta will be minus 1. So when does cos theta equal 1? Well, if we go back to our unit circle, remember we start here, we go anti-clockwise. Cos theta equals 1 when theta is 0 degrees, but it also equals 1 when we go all the way around back to 360 degrees. Remember, cos theta is the x-coordinate, and the x-coordinate is equal to 1 just here. When does cos theta equal negative 1? Well, that means the x-coordinate's negative 1. So remember, it goes 0, 90, 180. So theta there will be 180 degrees. So if I want to convert these to radians, as the question asked, you just times by pi over 180. 0 degrees is 0 radians, 360 is equal to 2 pi radians, and 180 is equal to pi radians. They are all the solutions, and we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.